So hi friends, so in this video we will see some more examples. So last video we have seen examples on unit step function or Haviside step function, right? Haviside unit step function or Haviside function. Okay, so in previous video we have seen, so function is polynomial in T or continuous function. Suppose if we have a discontinuous function, so how to solve those examples? Of course, we have two methods. For polynomial in T or continuous function, we have type 1 method. So type 2 method, when you have a discontinuous function. Here I am considering, so I am catching from some question paper examples, previous year question paper examples. Here example 3, express the following functions of Haviside unit step function. Whatever he have given function is a Haviside function, right? So a discontinuous function, so we need to express those discontinuous function in terms of Haviside unit step function. We need to express the given function in terms of Haviside unit step function, right? After that, and hence find their Laplace transform. After expressing the given discontinuous function in terms of Haviside unit step function, that Haviside unit step function, we need to find the Laplace transform of that function. Clear? So here we have 4 examples. 1, 2, 3, 4. We have 4 examples. These all 4 examples are in question paper examples. This question paper is first question paper question is December 2018. Second is June 2017. And third one June 2016 and 18. 2 times they asked. June 2016 as well as 18. Then last fourth one, this is also June 2018. June 2018, like this. So same pattern. So method is same. Now we need to see the solution. Solution of first example. Now you can say that by definition of unit step function, right? Or we can say by the property 3. We know that property 3. So how to write the f of t using the property? This is called as a Haviside unit step function. So we need to express that discontinuous function in terms of Haviside unit step function. Here we know that Haviside unit step function is, so f of t is, or f of t is, we have f1 and f2, right? T is lying between 0 to a, right? A is greater than a. E gives so we will express unit step function, so in terms of unit step function, f1 plus f2 minus f1 into u of t minus a. If their definition, right? E will come, E function. This is f1, this is f2. F of t equal to, so this is f1 is cos t plus f2 is sin t minus f1 is cos. Here f1 plus f2 minus f1 into u of t minus a. So in place of a, there is pi. So t minus follow. This way into represent the Haviside function or unit step function. That's it. This is the expression of Haviside unit step function. Unit step function. Right? So, ಇದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು ನಾವು? Hence, find their Laplace transform. So, ಇದಕ್ಕೆ Laplace transform ನ ತೆಗಿಬೇಕು. ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ಮಾತ್ರ ಏನು ಪ್ರಿವಿಯಸ್ ಮಾಡಿದಿಲ್ಲ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅದೇ ಈ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಸೆಕೆಂಡ್ ಟೈಪ್ ಒಳಗೆ ದೆನ್ ದಿಸ್ ಆನ್ವರ್ಡ್ಸ್ ಸೇಮ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಎ ಟೈಪ್ 1 ಏನಾಯ್ತಲ್ಲ ಆ ಸ್ಟೆಪ್ಸ್ ಇಲ್ಲಿ ಫಾಲೋ ಮಾಡಬೇಕು. ದೆನ್ ಅಪ್ಲೈ ದಿ ಲ್ಯಾಪ್ಲಾಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಆಫ್ ದಿಸ್ ಯೂನಿಟ್ ಸ್ಟೆಪ್ ಫಂಕ್ಷನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್. ಸೊ ಎಲ್ ಆಫ್ ಎಫ್ ಆಫ್ ಟಿ ಈಕ್ವಲ್ ಟು ಎಲ್ ಆಫ್ ಕಾಸ್ ಟಿ ಪ್ಲಸ್ ಎಲ್ ಆಫ್ ದಿಸ್ ಹೋಲ್ ಫಂಕ್ಷನ್ L of sin t minus cos t into u of t minus pi. I am calling this equation number 1. After applying the Laplace transform, I am calling equation number 1. Now find each term separately. So you can Laplace transform it, then each of it. Right? But this is what I am I can multiply by this side. So multiply by this. Right? ಈಗ ಮಾಡಿದ್ರೆ ಬರ್ತೈತಿ sin t into cos sin t into u of t minus pi minus cos t into u of t minus pi. ಸೊ ಎರಡು ಸಲ ಯಾಕೆ ಮಾಡ್ಕೊತೀರಿ ಸೇಮ್ ಟರ್ಮ್ ಬರ್ತವೆ. ಸೊ ದಿಸ್ ಈಸ್ ಟ್ರೀಟ್ ಆಸ್ f of t minus pi ಬರ್ಕೋತಿಲ್ಲ ಡೆಫಿನೇಷನ್ here. So first term simple is L of cos t we know that by the elementary Laplace transform. L of cos t is s by s square plus 1. Clear? So L of cos t s by s square plus 1. I am calling this equation number 1. Equation number 1. Right? Similarly, next one. Then this part, this is over. Then consider this part. Considering this whole part, L of sin t minus cos t u of t minus pi. This is equivalent to L of ಅಲ್ಲಿ small f ಬರ್ತದೆ. ಇದು already small f ಐತಿ. That's why I am changing the notation. Capital F of t minus pi, u of t minus pi. If you don't want capital F, you can write g of t minus pi. Just notation. That's it. Right? And let. Here, in place of f of t, we have this whole function. Right? This whole function. Capital F of t minus pi is this. This is equivalent. Capital F of t minus pi is sin t minus cos t. So we need f of t. Underly, this is equivalent to e raised to minus pi s pi into a pi into f of s. This already capital F. I am taking conjugate f of s. If you have this is small f, this is small f, this is a capital F of s. Clear? If you are taking capital F, notice it change it. Just I am writing conjugate capital F of s. Then this conjugate capital F of s antalla by definition of Laplace, this should be f of t again. Previous previous 1 and 2 example. So if t agutalla in place of t minus a, in place of t we need to replace e minus pi eliminate agಬೇಕು ಅಂದಾಗ t ಇದ್ದಾಗ t plus pi ಆಗುತ್ತೆ. T plus pi and pi cancel, we have only t. Now put t equal to t plus pi and capital F of t equal to sin of t plus pi minus cos of t plus pi. Cos of t plus pi. Then, so we know that the value of this from the allied angles, sin of t plus pi or sin of theta plus pi or theta plus 180. Theta plus 180 is, so this is minus sin theta or minus sin t. Then what about this cos? Cos of, I will move to here. Yes, I am written clearly here. Okay, nice. Now here this capital F of t is anyway, so value of sine of theta plus 180 is so minus sine theta. Then what about cos of theta plus 180? That this is also minus of cos theta. So minus into minus, that is plus, minus into minus plus cos theta t. Then take Laplace transform of this. L of f of t equal to then minus 1 over the L of sin t plus L of cos t. Again same, go for previous classes. So you know the value of this L of sin t and L of cos t by the element. So I am taking this conjugate of f of s equal to minus 1 by square plus 1. So this L of cos t is s by s square plus 1. Now simplify this. Take LCM. So LCM is s square plus 1. So minus 1 plus s. I can write s minus 1. Right? So this. After getting this, now substitute here. This whatever you have considered. Now L of capital F of t minus pi into u of t minus pi into e raised to minus pi s into f bar of s, conjugate of f of s. Now, so we need this. This is nothing but sin t minus cos t into u of t pi, which is equal to e raised to minus pi s into this is equal to this. This is nothing. I am replacing here s minus 1 by s square plus. So I am calling this equation number 3. Equation number 3. Now substituting equation 2 and 3 in 1, we get L of f of t equal to s by s square plus 1 plus e raised to minus pi s into s minus 1 by s square plus 1. So if we left here, this is the result, or same LCM equivalent. Again this s square plus 1, right? So s plus e raised to minus pi s into s minus 1. So this is the required result of given example, given discontinuous example, right? Similarly, this example, second example. Earlier second example you have only first example f of t is you have two sub function, right? Two sub function cos t and sin t, cos t and sin t in the interval, so 0 to pi, then t is greater than pi, second function. But second example reverse, so sin t and cos t, sin t and cos t. So interval is so 0 to pi by 2, then t is greater than pi by 2, and pi equal pi by 2, pi equal pi by 2. See, now so your function is f of t is sin t, right? Sin t, then cos t. The sin t is 0 to pi by 2, and t is greater than pi by 2. This is the function. This is the function, right? So here we have this f1, f2. Now f of t. So we need to express this given function in terms of Haviside unit step function. So f1 plus f2 minus f1. f1 is sin t, f2 is cos t, and now again f1 is sin t into u of t minus pi by 2. T minus pi by 2. Same procedure, right? At pi equal pi by 2. Then again take Laplace transform of this. L of f of t equal to, I will write directly. Separate direct okay. L of sin t is 1 by square plus 1 plus. So we need to solve this separately. So L of cos t minus sin t into u of t minus pi by 2. So direct ಗೊತ್ತಿದ್ರೆ ಬರೆಬಿಡೋದು. So ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಬರೋಕ್ಕೆ ಬರೋಂಗಿಲ್ಲ. So we need to solve, right? So this I am calling equation number 1. Now consider L of cos t into cos t minus okay, cos t into L of cos t minus sin t into u of t minus pi by 2, which is equal to same L of f of t minus pi by 2 into u of t minus pi by 2. This f of t minus pi by 2 is this cos t minus sin t. Then here, so t is replaced by t plus pi by 2. T plus pi by 2. So t plus pi by 2, right? So my plus pi by 2 minus will be cancelled. We have only t equal to cos of t plus pi by 2 minus sin of t plus pi by 2. Again, other angles. We have theta plus 90. Cos of theta plus 90 is minus sin theta. Then sin of theta plus 90 is here only cos theta plus cos theta plus cos theta. So cos theta, right? Minus 90 minus cos theta. Okay. Now take the Laplace transform of this. Take the Laplace transform of this. So shall I write this one? Here. Or you can solve here. Okay. Nice. Now moving. Yes. Now here. Now this is nice. L log second example. L log capital F of t equal to then L log we have minus. So minus I am taking outside minus sin t again minus L log cos t, right? And this conjugate of capital S of S equal to minus of, so A is 1. So L of sin t is A by S square plus A square. So A is 1, so that's 1 by S square plus 1. Then minus, then here your cos AT is S square plus A square. So which is equal to, so both you have same is same. So you take minus outside, this is S plus 1 divided by S plus 1. Clear? LCM is S square plus 1. Then so minus is minus minus S minus 1 minus 1 minus S, so S square plus 1, right? Then L of capital F of t minus pi by 2 into u of t minus pi by 2, which is equal to e raised to minus pi by s into s, so minus pi by 2 into s. Capital S F conjugate of S. Right? This is we know that by the property 2. By the property 2. You can say by 2 property 2. You can say by property 2. Then similarly, so that what is this capital F of t minus pi by 2? We have cos t minus sin t into u of t minus I by 2, which is equal to e raised to minus pi by 2 into s. F bar of s is this here. So minus, we can take minus here, or we can take minus of s plus 1 whole divided by s square plus 1, right? Or which is equal to minus of u minus I is equal to into s plus 1 by s square plus 1. All this is equation number, I think it's 2. Then substitute equation 2 in 1. Right? 2 in 1. Now substituting equation 2 in 1. 2 in 1. Now equation 1 is L of f equal to, so already we have written, so 1 by s square. L of cos 80 is 1 by s square. So sin it, right? Plus, so equation 2 is minus with the s, minus e is to minus pi s by 2 into s plus 1 by s square plus 1. So this is the required solution. Let's start. If we have any more simplification, we can do here s square plus 1, s square plus 1, or this is s square plus 1, right? Then 1 minus e is to minus pi s by 2 into s plus 1. This is correct. This is the answer of the second example. Clear? Nice. Similarly, third example, I think it is visible. Yes. Third example, f of t equal to f. So previous two example we have only two sub-function f1 and f2. If you have three sub-function, one f of t is 1, so t that is 0 to 1, t is 1 to 2, then t square is greater than 3, greater than 2, like this. Similarly, fourth one, cos t, then 1 sin t, then cos t is t0 to pi, so this pi to 2 pi, and this is greater than 2 pi. Now as it is, we follow here solution third one, right? So that of this one. Okay. Here third one, solution of third one. Same procedure. So third one actually you can do fourth one. You can do homework as fourth one. Okay. Nice. Here, right, or express this discontinuous function in terms of Haviside unit step function by using property 3 and 4. Particularly, if you have only two sub-function, use property 3. Then if you have three sub-function, use 4 property. Same procedure. So f1 of t plus f1 of t plus f2 of t minus f1 of t, correct? u of t minus a plus f3 of t minus f2 of t into u of t minus a. So this is fourth property definition. Fourth property is a statement. So that's then same we are following. So this is f1, f2, f3, right? f1, f2. How value that? F of t, so f1 is 1 plus f2 is t minus t square into u of. See the a is actually, so t minus 1, correct? Plus then f3 is t square minus t into u of t minus. In place of t we have 2 number. So this is the, we need to express in terms of Haviside unit step function. Now applying the Laplace transform on both sides. L of f of t equal to L of 1 plus L of t minus t square into u of t minus 1 plus L of t square minus t into u of t minus 2. So this is equation number 1. Or you can, okay, equation number 1. We'll direct L of 1 antara 1 by s, right? So now solve separately or, okay, solve separately, right? So now first one, L of 1 and L of 1 is 1 by this. Then L of this. So next consider, this is equation number 12. Right? L of 1 is 1 by s. Then consider, so next one what will happen? Then L of t minus 1 into, correct? Okay, t minus 1, correct? But then yes, t minus is 1. Okay, because f2 minus f1, f2 is t, f1 is 1. This is correct. Then here t minus 1, t minus 1. Then t minus 1 into u of t minus 1, right? T minus 1. So which is equivalent to L of, so let take capital F of t minus 1 into u of t minus 1, right? So here in place of f of capital F of t minus 1 is again t minus 1. So here capital f of t minus 1 equal to t minus 1, right? So we need f of t, f of t, which implies f of t ಬೇಕಂದ್ರೆ ಈ ಮೈನಸ್ ಹೋಗಬೇಕು ಅಂದ್ರೆ t ಇದ್ದರೆ t plus 1 so capital F of t equal to here again t plus 1 ಈಗ ಮತ್ತೆ minus 1 ಹೋಗುತ್ತೆ plus 1 minus 1, so we have only left with t, so take Laplace transform of this, only this, right? So right here. Nice. Again an example. I think it is visible. No. Okay. Here. So L of capital F of t equal to L of t. Right? We have only these terms. Capital F of t by equal to t. So if you take Laplace transform of this, so capital F of t is conjugate of capital F of s. Simply small f of t idre capital F of s ಅಂತ ಬರೀತೀವಿ. So ಸ್ವಲ್ಪ notation change ಇದೆ ಯಾಕಂದ್ರೆ capital F ಐತೆ, right? Don't confuse. So L of same, both are same. Alternative L of t is, so this is basic elementary transform of L of t is, so 1 factorial 1 s is to 1 plus 1 is, so 1 by s square. L of t is 1 by s square. So now after getting this, now here, so which is equal to e raised to minus 1, so minus s into f bar of s, f bar of s. F bar of s in this. So L of t minus 1 into u of t minus 1 equals to e raised to minus s into this 1 by s square. 1 by s square. On calling this equation number 3, equation number 3, right? Then similarly, because last then next term last term. So L of, so L of t square minus t into u of t minus 2 equals to, so this is exactly equivalent to capital ತಗೊಂಡಿವಲ್ಲ, you can take capital G of t minus 2 into u of t minus 2, right? In place of capital G of t minus 2 is this. So that capital G of t minus 2 equal to t square minus 2. Again same procedure, t minus capital G of t ಆಗಬೇಕು, ಅಲ್ಲಿ minus 2 ಎಲಿಮಿನೇಟ್ ಆಗಬೇಕು ಅಲ್ಲ. So put t equal to t plus 2. So that implies capital G of t, t plus 2 ಆಗಬೇಕು. So cancel ಆಗಬೇಕು, only t here t square, so t plus 2 t square minus t plus 2. Solve ಮಾಡಿ, is equal to t plus 2 whole square is a plus b whole square, t square plus 4 plus 4 a square plus b square plus 2ab minus t. So bracket ಬಿಡಿಸಿ, minus which is equal to, this is capital G of t, so t square, and this is plus 3t, 4t minus 2 is 3t, then 4 minus 2 is plus 2. So t square plus 3t plus 2. Now take Laplace transform of this, equal to L of t square plus 3L of t plus L of 2. So this is conjugate of g bar of g of s equal to L of t square is, so 2 factorial divided by s cube plus here 3 into 1 factorial by s square plus 2 by s, right? Then so once we get the g bar of s, so which is equivalent to here e raised to minus 2 into s, as minus 2 into minus a in place of a minus 2 into s into g bar of s, ये मुझे प्लस भी डालते हैं. Now therefore L of t square minus 3 into u of t minus 2 equal to e raised to minus 2s into that g bar. So 2 factorial is 2 by s cube plus 1 factorial is 1, so 1 into 3 is 3 by s square plus 2 by s, 2 by s. Correct? So this is equation number 4, I think, right? Equation number 4. Okay. Equation number 4. Yes. Equation number 4. Okay. Now substituting equation 2, 3 and 4 in 1. So 1 ಗೊತ್ತಿರಬೇಕು. So L of f of t equal to, so first term ಏನೈತೆ, first term is, so L of 1, so the equation number 2 is L of 1 is 1 by s plus, then equation number 3 is, yes, here equation number 3 is e raised to minus s into 1 by s cube plus, then equation number 4 e e raised to minus 2s into 2 by s cube plus 3 by s square plus 2 by s. So which is the required solution of this third example. So no need to further simplification because there is no common term. So all of the s cube, nothing one. So if you take any common, you can take. Otherwise, okay, like this. This is the final third example. Clear? Now similarly, you can try this example. Fourth one. Same method. Fourth one is f of t equal to cos t in the interval 0 to pi. So one is pi to 2 pi. Then sin t is greater than 2 pi. Similarly, 2 pi to infinite terms anta. Yellow same idea. See, I will write f of t of this. F of t equal to right here. So this implies f of t equal to same f1, f2, f3. So f1 is cos t plus next f2 minus f1. Ft is 1 minus f1 is cos t. Then u of t minus then plus f3 minus f2. F3 is sin t minus 1 into u of t minus last 2 pi. So this is f of t. This is f of t. Now take Laplace transform L of cos t, L of this whole function, and L of this whole function. This is called as Haviside unit step function. L of f of t. After expressing if you multiply with u of t minus 1 or t minus 8 in terms of t minus 8 the unit step function or Haviside function. Multiply the function right in the function. This Laplace transform now use properties. Property 2 ultimately. Property 2. Now separate this one. Take this capital F of t into u of t minus 5. Then this capital G of t into u of t minus 2 pi. Solve capital F of t and capital G of t. Then substitute here. Then that is the answer. Hello. Now try this example. Fourth one.